we know things are complex. If we can understand the complexity better, maybe we can understand better how these systems work.
This is Defender Radio. I'm Michael Howie, and this is Defender Radio, the podcast for wildlife advocates and animal lovers, brought to you by the Fur Bearers. How are ecosystems responding to the warming of the planet? It's a big question, and there isn't a single answer. But specific questions are being asked to help build a better idea of what's happening globally. Two such questions were asked by Dr. Ben Freeman and his colleagues in a paper published in Global Ecology and Biogeography titled Expanding, Shifting, and Shrinking: The Impact of Global Warming on Species Elevational Distributions. Specifically, Dr. Freeman tested a classic ecological theory that predicts temperature more directly influences species' cool range limits than their warm range limits. They also tried to determine how warming-associated shifts have changed the extent and area of species' elevational distributions. To explain what the team found, as well as why it matters and how it could influence our thinking and policy creation, Dr. Freeman joined Defender Radio. Let's talk about the classic ecological theory. So this whole paper that you've put together, which is immense in its scope, there's sort of two objectives you were looking at. One was to test classic ecological theory that predicts temperature more directly influences species' cool range limits than their warm range limits, and to determine how warming-associated shifts have changed the extent and area of species' elevational distributions. So I just read that verbatim from the paper, as you know. Perhaps we should start perhaps we should start with an explanation of what those two concepts are, in more simplified terms.
Right. So a big, a long-standing question, fundamental in ecology, is to try to understand why species live where they do. Mm-hmm. So it's just a fact of life that the species that live in one place, you travel a couple hundred kilometers and you'll probably find a slightly different set of species. You keep traveling away and you'll find different species. Anywhere you live, anywhere you visit on the globe will have different species. So why is that? Why do species live in one place but not another? And the answer, of course, is that it's complicated, but there's been a search for generalities. And one thing that we know is important is just general climate, which is often summarized by the temperature. And we know this is important through time. So during the ice ages, it was a lot colder, beyond the fact that just much of Canada and northern United States was covered with ice. It was colder everywhere, and species that now live, say, in Vancouver during the Ice Age maxima, they lived much further south, where it was maybe a climate similar to Vancouver today. So there's this idea that climate and temperature are important to understanding why species live where they do. And then there's also this idea that maybe climate and temperature are most important at the colder end of things. And so the idea being that when you get to a warmer climate, that seems like that should be an easier place for species to live, less challenging to them. But then as you move north or as you move higher on a mountain, it gets colder and often dramatically so. And that's kind of a little bit more obvious factor that you could imagine would be challenging to a species. So a species that lives in Vancouver might not be able to live up in the Yukon because it's so damn cold there. Mm-hmm. So that's the basic kind of conceptual idea behind this kind of long-standing idea that was maybe first pointed out by Darwin. So this is this idea dates back over 150 years. But this idea that cold temperatures are really challenging to species. It's hard for species to adapt to cold temperatures. And if that's so, then a corollary is that it's cold that often limits a species at its northern range limit or at its upper elevation range limit. whereas at its southern range limit or its lower elevation range limit where it's warmer, people have said, well, maybe it's not. It's a little more difficult to understand why being a little bit warmer would be so challenging for species.
Well, I can personally say that when I'm a little bit warmer, I just can't do anything right. I'm a cold weather species, so I understand that basic concept. And of course, the second part of that is how warming associated shifts, so changes in temperatures and ecosystems, have changed where species live on an elevation. And
that's right.
You looked at, and this is staggering to me, 975 species. Including, in fancy terms, vascular plants, endotherms, and ectotherms, which are plants that have something to do with temperature, based on my rudimentary understanding of Latin, and cold weather animals and warm weather animals.
Yeah, it's basically it's plants, and then so plants are trees, shrubs, grasses, small flowers, that whole mix. And then endotherms, just meaning species that produce their own heat, regulate their own metabolism. And that's things like birds and mammals. And then ectotherms are things that have less capacity to regulate their own body temperature. So those are things like insects and lizards. And yeah, we were able to get this really large number of species because there's been a lot of interest in understanding how recent warming is changing where species live on Earth. Mm-hmm. And it's easiest to study that along mountain slopes, because if you're at the base of the mountain, it's warmer and it gets predictably colder as you go higher on the mountain. So within a pretty short geographic span, you can maybe hike from the bottom to the top of these mountains in less than a day. But you can go from a very often hot climate at the bottom of the mountain to a very, very cold climate at the top of the mountain. So it's almost equivalent going from the bottom to the top of the mountain. It's equivalent to, say, going from Mexico to the Arctic in terms of climate on a lot of these mountain slopes.
And the results, if we skip over the scary numbers, show that there was no actual evidence saying that it's easier to go between cold to warm versus warm to cold.
Yeah. So what we find is that, pretty much across the board on Earth right now, it's getting warmer. Mm-hmm. And some places are getting warmer faster than others. So places like in the Arctic and the boreal forest are warming quite a lot, whereas in the tropics it's warming relatively small amount. So everywhere it's getting warmer. And so species in general in our data set, they're living at higher elevations now than they used to. But the amount at which they're moving up at their cold limit is about the same as the amount they're moving up at the warm limit. And there's a ton of variation there that we can't explain. But what we can say is that it doesn't seem to, temperature seems to have a similar influence on species' warm limits and their cold limits.
I suppose one of the worrisome things, if we look at it from the sort of broad ecological standpoint, though, is that there's a whole lot less space at the top of a mountain than there is at the bottom of a mountain, so to speak.
Right. So that's as you pointed out, we had two goals in our paper, and one was kind of an ecological theory goal that I think is pretty interesting, but is definitely firmly within the realm of kind of academic concepts. And then, but it's the flip side of that is this basic conservation question: is as species move where they live in space, does that matter to them? Do they get squeezed into smaller areas, or do they actually get access to a bigger area that would be beneficial to them? And as you say, what we find is that the answer depends on where on the mountain the species live. Most, but not all mountains are shaped roughly like pyramids. So as you go higher and higher, there's less and less area. And so these high elevation species have been predicted to shrink in their distribution because they're living at progressively higher areas, and the mountaintop is just a fixed barrier. So they're predicted to be squeezed into smaller areas. And what we show is by compiling data for all these different plants and animal groups across the globe, that does seem to be what's happening.
And there's a note in the conclusion that biotic interactions play a more prominent role in setting range limits than previously thought. Could you explain what that means?
Yeah, so again, it's this question of why does a species live in one place but not another? And this idea has been that we can kind of separate the influence of how that animal is influenced by climate versus the influence of how that animal interacts with other species that it eats or that eat it or that compete with it for food. So things like bobcat and lynx, like you could say that lynx is limited by climate, that lynx maybe need to have a place with enough winter snowfall that they can hunt successfully. And that I think you could probably make that statement, and a lot of people might just say that sounds reasonable. But it's probably also limited by biotic interactions with bobcats, which are its competitors. And so there's basically what we're saying is it's a very in practice difficult to separate the influence of climate directly versus all the interactions that species have with one another in determining why they live where they do.
And that's and I'm going to go a little tangential on you. It's a very interesting concept. And as a non-scientist who has very simply an interest in ecology, I often wonder when we have conversations about hunting, trapping, general conservation, land use planning, development, the way we look at, okay, well, this is the species that are there and what we need to do to make sure everything's okay, seems vastly oversimplified when I then turn around and speak with people like yourself who are studying these minute interactions. Can this kind of research that you're producing with your team then help inform those conversations and say there's more to this?
So, I mean, that's the idea, right, is that, we know things are complex. If we can understand the complexity better, maybe we can understand better how these systems work. And that's a very alluring goal. And that goal is definitely true in some sense. Whether it can be true in a helpful sense is less clear, because it's easy to just say, oh, it's really complex.
Yeah.
And then that in and of itself doesn't actually change any sort of decision making. So I actually think I was about to say there's some examples where kind of the knowing a lot more of the details is really helpful. But I'm struggling to immediately come up with a great example. But the details are complex, and then also species are able to adapt and evolve to changes. So nature is not static. And so I think these studies of range limits are interesting to consider in that context. The studies that are really helpful for kind of management recommendations do require burrowing down on single species that live in a single area and trying to understand what's important for them. So there have been great studies of caribou in Western Canada and in the boreal and tundra, where people have really figured out what's important for caribou in the Kootenays in British Columbia, what's important for woodland caribou in northern Alberta. So folks really understand what's important for them. But I think it's always going to take kind of focused studies of the species that you're interested in to understand what's important. It's alluring, but probably won't be that helpful to take these really general studies and then use those to infer what's important for specific populations.
That makes sense. I guess it's more it can serve as a reminder when we are then looking at individual species. That's in looking at individual species, we have the potential to miss some things. I think, talking about the caribou is fascinating because, and I won't make you comment on a political issue. I know that makes many researchers uncomfortable, but we understand exactly what these caribou need. And the policy that comes out of that is completely opposing that. I think.
Yeah. So that just gets at the fact that the biology side of conservation is one component, but is by no means the thing that drives decisions.
Mm-hmm.
So, I mean, for most issues of conservation interest, we kind of know more or less that if the large majority of plants and animals do pretty well if we leave their landscapes more or less untouched.
Mm-hmm.
It's trying to figure out, when there's areas with extensive human development and land use change, then some species will be sensitive to that, and as you alluded to, the fact that we know what caribou would need in order for caribou to mount a recovery does not mean that that's the decisions that we're going to make as a society or that politicians are going to make.
Yep. And they have different priorities. But the other one that's interesting is the pikas, I know. And I imagine, what are these? Are they marmots? Marmots are the ones I'm thinking of. Vancouver Island marmots. Mm-hmm. I know that they're one of the species that climate is severely affecting and falls right into this very interesting work you've done. Right. I've spoken with someone from their organization in the past, and I'll get it wrong if I try and recall, but I know it does have to do with climate as well as development.
Mm-hmm. And that's a particular case. So you have in that case a marmot, this large rodent that lives at high elevations only on Vancouver Island only. And there are plenty of high elevation habitats on Vancouver Island, but there's not a ton of them. And these are near the mountaintops, so they're not large areas. So we're talking about a relatively small number of areas that are all relatively small in size. And that's the kind of thing where our research is applicable to, as saying that yes, your baseline expectation should be that marmot will most likely start to live at higher elevations and shrink in distributional size, and that likely means a shrinking in the size of the population as well.
Mm-hmm. And unfortunately, that species is in a very precocious point right now, and can't necessarily afford to shrink.
Right. So this is for those kind of things. It's unclear. It's unclear what one does with that information if the goal is to provide the environment for the marmots to persist for the foreseeable future. If we know that they're likely going to be moving to higher and higher elevations, it's been a big challenge to think about what that means for what decision makers on Vancouver Island in those places do.
I do not envy the position of people who have to figure this out. I do envy the position of people like you who get to do all of the fun stuff, though. And people who want to learn more about this kind of science or want to support this kind of science, which I think as we learn more, these little pieces come together and we get these really interesting looks at the world. And again, you're taking what you've done and we can start applying it to various species, such as Vancouver Island marmot, talking about bobcat and lynx. And I know in northwestern United States, Canada lynx, the status of the species is constantly towing the line of endangered, or at least at risk. And a big part of that conversation, again, is climates. So for folks who want to support this, want to see more of it, want to learn more about it, what is really the best way they can go about it?
Man, yeah. I think for folks that are interested in this, then, the absolute best thing to do is to go out yourself in nature in some place that's close to where you live and learn about what's going on there. Because ultimately, these things are meaningful to the extent that we personally care about them, and we're going to care about the things that we interact with and cherish ourselves. So, the most important thing is really to get outside and observe what's going on and join a local group that enjoys and monitors and looks at the plants and animals that live around you. For these kind of science studies, then scanning the various media publications and websites that summarize and translate some of the scientific studies to a general audience. I'm checking various newspapers every week to read what's going on in science, because science is I understand my small field, but there's a lot of cool stuff going on that you would like. Just yesterday, I was seeing this video of this gulper eel that ingests and lives in oceans, and it is able to bring in water into its body and basically inflate like a massive balloon and just totally changes its shape. And I don't know, those kind of things I think are really inspiring, just reminders of how cool the plants and animals that we share our planet with. Those are really inspiring to me.
Mm-hmm. Yeah, I love, there's some really good science journalists out there. And again, I do not have a scientific background, as you probably picked up during this interview. I do have a journalism background, though, so it helps to understand what I don't know. But I feel that the field of science communication is growing right now. And I'm very grateful that there's people like you who are very good at communicating about your work, so the rest of us can kind of get a better understanding of it.
No, thank you. Yeah, it's like you said, there's both a big market for science journalism, and there's a really good supply of it as well.
You can read the full study through your preferred academic website, or by following the links in this week's show notes or in the blog at thefurbears.com. I want to thank Dr. Freeman for joining the show to explain his academic findings, and all of you for checking out this week's episode. Remember to follow me on Facebook and Twitter at Defender Radio and Instagram at Howie Michael for updates on new episodes, contests, outtakes, and adorable photos of JJ the Hamilton Hound. Until next time, I'm Michael Howie for Defender Radio, reminding you to stay informed and stay strong.